All right, good afternoon, everyone. My name is Ken Rudin, and I run the analytics function at Facebook. Been there a few years. Big data movement has already had a big impact on our economy and changed the way that a lot of us are doing business. But in addition to that, it's also creating a new economy. And with that, there's a lot of new opportunities as well. And that's really what I want to talk about. And I refer to that as the data economy. So historically, we started off as an agricultural economy where the focus was on growing things. And then people started creating machines. And as we started creating machines to help the agricultural economy, that whole movement itself created a new economy, the industrial economy. Then we started focusing on building things. And as we start focusing on building things, we start creating some factories. And as we create factories, we start to want to capture data about how these factories are operating and figuring out how we can optimize the operations within these factories. And as we collect more and more data, that becomes the foundation of the data economy. And the focus of the data economy is on understanding things. And so that's where we are today. And not only does it help the prior economies, the agricultural and the industrial economies, it also creates a new economy with new opportunities, and that's what I want to talk about today. Next slide. So in my role, I have the fortunate opportunity to see a lot of great new startups and talk to them fairly frequently. And when I look at opportunities in the data economy, they really cluster in about 4 different areas. There's the area of figuring out how to gather data more simply and implicitly. Then there's the area of how do we store data in new ways so it's easier to store and easier to retrieve. There's the area of new ways to analyze data. And then the 4th big area is generating algorithms based on the data we've seen that help improve the status quo of certain processes or certain ways of doing things. Many of the time, these things are currently done manually, and we're replacing them with algorithms. Then I'll also talk a little bit about where creativity fits into all of this. Let's start with the gather notion itself. It wasn't that long ago when something like this was state of the art. You had a stopwatch, you had a pen and a clipboard, and this was the way that you captured data. And this was the start of Taylorism and so on, where people were looking at information in very, very small amounts because there was no easy way to capture it. All the data back then, and even today, the vast majority of the data we capture is explicitly captured. And by explicit, I mean that the user or the employee has to do something explicitly to generate the data. We ask users to fill in a form, or we ask an employee to manually scan items as they go through a production line. The real opportunity now in terms of big data and the gathering of data is how to do that implicitly, how to do it automatically. Next slide. There are a couple examples of this. The first one I want to talk about is capturing video images. These are just these are 3 of many, many different examples, but we now have the ability to very inexpensively and very easily capture live streaming images from remote areas so that we can detect events. And in my case, I used one of those devices in a house I have in Lake Tahoe, and late last year at about 2:30 in the morning, I get an alert saying that there is activity detected in my house. I can quickly go online, roll back the video about 15 minutes, and see that I have a big black bear in my kitchen. And I have the video on my phone if anyone wants to see it afterwards. It's quite exciting, very exciting at 2:30 in the morning. And then I'm able to call the local police and ask them if they would kindly escort the bear, not just out of my kitchen, but out of the house in general. GPS enables us to capture in a constant, continuous way, and again, implicitly capture the location of users with their permission, of course, and allows companies like Uber to now identify where you are without you having to use the old mechanism of picking up a phone and dialing a dispatch. We have things like RFID chips that replace the notion of manually scanning items. Now it's all done automatically. Next slide. There's also these types of devices, wearables, that are now becoming very popular. And not only do these devices have a large number of sensors on them for things like GPS and so on, they also allow us to capture things we never could capture before in any kind of volume, particularly health information. So these devices now can capture a lot about what's going on with your health and with your body. The only way we could do that before was an extremely explicit way of you had to go to the doctor once or twice a year, and they would capture information. They'd get 2 data points on you a year, at best. Now we can capture continuous information that can change the entire industry for healthcare. So let me talk about a few industries where I'm seeing some really interesting things going on. Again, pretty much any industry you could apply this to. I'm just choosing 3 here. So in the logistics, there's a company called Weft, and they make a small device, that little black box you see there. It's a little larger than your cell phone. And you stick that on these metal shipping containers. And it's completely self-contained, battery-powered, lasts for about 2 years, very, very inexpensive. You put it on every shipping container you've got. And not only does it tell you the exact location in a continuous fashion of where your items in that shipping container are, because a surprisingly large number of shipping containers get left on the dock accidentally as the ship takes off. But it also tells you temperature, it tells you humidity, and it tells you if the container has been jostled, so you can reduce spoilage in your inventory. So the type of information now that they're getting back that streams in continuously about exactly where it is, where your products are, helps you optimize this entire business, the whole logistics chain. Next slide. If we look at agriculture, a company like Eden, where they have a very simple way of collecting data about what's going on with farmlands or consumer backyards as well. You buy these inexpensive self-contained devices. They're solar powered. You stick them in the ground, and you can stick them in every 30 yards or so to get the microclimates and the micro sensors about what's going on in each area of your farm. You get sun information, you get temperature information, you get information about the moisture in the soil, you get information about the nutrients in the soil. You can decide exactly which areas need water and which ones don't, rather than just turning on the sprinkler system for the entire farm. So again, optimizing agriculture in a great way by figuring out a way to capture this data much more simply than we ever could before. And then next slide, please. It's not all about creating devices either. Yet the insurance industry is able to take advantage of some of these devices. So John Hancock has released an app called Vitality that takes advantage of the health information coming from your watch. And they're using that to give you discounts on health insurance. The more active you are, the more you exercise, you get more discounts. So it's giving them a huge competitive advantage to pricing health insurance more effectively than we ever could before. Whereas everyone else is still using generic information and demographics like age and gender, and that's all they can base it on. The next area I want to focus on is storing information. As soon as we learned how to write, we effectively learned how to store information. So this is an old Sumerian tablet capturing information about the owner's beer supply. Apparently, the little triangle marks you see are the symbol for beer. So not a lot of information, not very dense. And if we go to the next slide, we've certainly made huge strides in just the recent decade, so we can store massive amounts of information in data centers like this. But this isn't the opportunity that I see in big data. Yes, there will still be an opportunity to store information, more information in less space, but that's not the type of information and the type of opportunity I'm talking about is different ways to store and retrieve the information. So historically, we started with row-based systems, relational databases, and that covered a broad range of needs, but by no means is a row-based mechanism optimal for everything. So that creates a whole new set of opportunities as we look at more data, more types of data, and more ways we want to think about data. So the columnar storage database came around with companies like Vertica and others, which gave us a better way of retrieving and querying large amounts of data. And then we started thinking about data not in terms of rows and columns at all, but in terms of nodes and objects and how they interact with each other. And then you get companies like GraphSQL that come up with a database optimized for letting us think about data in a very new way as a graph instead of spreadsheets and columns. There are things like MongoDB, which allows us to store data as an entire document, a structured document, instead of trying to break it down and cram it into a row and column interface, which doesn't really make sense when I want to store complicated objects in their entirety and be able to bring them back in their entirety. And then in-memory databases are solving a lot of problems right now because they're using the attribute that memory is extremely fast, the price is dropping quickly, and the latency of getting any piece of data from anywhere in memory is constant. so you can rethink how quickly you can access data and what you can do with it. So we've talked about how to capture data. More simply, we've talked about how to then store it. Once you store it, the next thing is to analyze it. If we look back historically again, it used to take a computer that would fill a room about that size just to get enough processing power to do some basic analysis. If we look at where we are today, we get 100,000 times more power, maybe even 1,000,000 times more power that fits on top of your desk. But as with storage, this isn't the opportunity I'm looking at. It's not really going to be in the area of cramming more processing power in less space. There are a few there, but I think the majority of the opportunities come in, next slide, with what we're doing with different kinds of analysis, using the processing power we've already got to do things we're not yet doing. So with all of this data, one of the things we really need, huge opportunities out there to find better ways to predict what's going to happen next. We have much more fine-grained data. We can detect signals much smaller than we ever could before. And with those signals, we can detect patterns. And if we see that pattern appear again, we often know what's going to happen next. So we need more tools that can focus on better prediction. Categorization is really important as well, because with so much data, I can't think about each data point individually. I need ways to cluster it automatically together, to categorize it, to group it together. I need better machine learning tools and data mining tools to automatically discover anomalies in my data and help me find insights that I didn't see before. I need tools that give me a different way about thinking about the data, not in terms of numbers, but in terms of visuals. Our visual processing system is amazingly powerful and it can detect signals very, very quickly, if only we can figure out new ways of visualizing it. So enormous opportunities to visualize in brand new ways all this data we've got. And then transform the data. We've got so much data coming from so many different sources. We need some way that we can combine it all much more automatically than we're doing today. And I've seen some companies that are focusing on this as well. So I can think about all my data in a uniform way. The last thing I want to focus on is algorithms themselves. Once we've got the data captured and we've stored it and we've done some analysis, now we can capture some algorithms, create some algorithms that allow us to improve the status quo about how things are done. So if we look at optimizations, one of the areas where I'm seeing this most effectively. Now, let me give just two examples. Historically, the status quo of how we optimize energy usage in our houses, we didn't do it. We set the thermostat and we left it. But with now a device like Nest or any of the breed of network-connected thermostats, you can constantly stream data back and then optimize energy usage in your home. And not only is it good for homes, it can also, in aggregate, look at energy usage for entire communities and help us optimize what we're doing with the energy grid overall. We couldn't collect this data before other than having somebody go out and read your meter once a month. Now we're getting data continuously. If we look at something like Waze, the status quo of how you optimized your traveling routes was we'd send somebody up in a traffic copter looking at the traffic, and they would tell you what they saw and tell you which way to go while you're listening to it on the radio in your car already stuck in traffic. Now we've got streaming data continually sent back to Waze servers about where you are and how fast you're moving, and it can, in real time, keep updating the route to give you the optimal way to get to your destination. Next slide. If we look at recommendations, in healthcare, the recommendation came from, well, you hope your family doctor knows what he's doing. But now we're taking systems like IBM's Watson, which was originally built to beat world champion Jeopardy players. Now they're pointing it at massive amounts of medical information, ingesting all of that, and using it to enhance and improve doctor recommendations. When we look at news, the status quo for news that we can now improve because of big data and these algorithms was you'd have a news editor choose the articles that they felt the community would be most interested in. But now there are companies like Facebook, which uses information that you've provided about what you like and what you like to engage with, and in a few milliseconds, we can create a news stream for you that has things that are most tailored to what you're interested in. The status quo for the apparel industry was you'd go to Nordstrom and get a personal shopper. Now you have companies like Stitch Fix that ask you a few basic questions about the style you like, and then they use algorithms to figure out which types of articles of clothing will not only match the style you're interested in, but also will go well together. And they can do this on a massive scale. If we look at the last one, monitoring, with so much data coming in, it's no longer possible to do this manually. Status quo for figuring out what companies are saying about you in social media was get a bunch of people to kind of sample a bunch of comments that are going on, that are being written and summarize that and tell you the sentiment. Now we've got companies like Radian6 that do that automatically. And we've got companies like Splunk that can monitor your external and internal network traffic to tell you when there's a likely network failure or tell you when there's a network attack. All of these done algorithmically on very, very large data sets, and there are more opportunities like that. Next slide. Now, I've talked about things in the area of gathering and storing and analyzing and creating algorithms, but that's all about computers and storage and data. It's missing one key element, which is the element of human creativity. There was no analysis. If you can go back, please. There was no analysis that was done that said we need a new way to search the web that created Google. There was no data that identified the need for a social network that led to a company like Facebook. There was no computer that said we have to create a new database system that led to the creation of Hadoop. Those all came from human imagination and creativity and inspiration. And that's still the place where the carbon in your head, your brain, still outperforms the silicon in your computers. And though I'm talking about creativity last here, in reality, it should be first, because everything starts with the idea. Because in reality, technology will help you get the right answer. Really, it's creativity that helps you ask the right questions. It's creativity that is at the foundation of any of these great companies that you guys are starting. And ultimately, it's our aggregate creativity that's driving the overall data economy. Thank you.